All right, we have 17 people in the call, still going up slowly. I'll make it a 1 or 2 minute introduction and then we can get going. We had quite a few sign-ups, so I'll give them a little bit more time, but let's get started. Thanks for coming the day before we head into the long Easter weekend. Everybody's keen for that break. I can't wait, actually. But before we start, I would love to begin by acknowledging the traditional custodians of the land on which we meet today, which for me is the Gadigal people of the Eora Nation, and I want to extend that respect to all the Aboriginal and Torres Strait Islander peoples here today. We are hearing today from Tim Devlin, who's the chair of our Engineer Timber Working Group, which will also be starting soon. He'll tell you some more about it. Tim is not only the chair of the working group, he is an architect and works for Theca Timber, and he's their New South Wales and ACT manager, and he'll tell us today about the wonderful Sydney Fish Market timber roof construction. So we will do with the show and tell as we always do, as we have done in the last time. I will hand over to Tim. He will present. You can put questions in the chat or just wait until he's finished, and then we'll open the room for anyone to ask a question. We can also look at the chat if there are any questions if you don't want to move up, but look at this as an open meeting where you can just raise your hand or insert yourself into the conversation if and where you feel it's the time for it. So with that, I hand over to Tim. Thank you.
Thanks, Katie. Hi, everyone. Hope you're all doing well. So I'm coming to you from Western Sydney, which is Darug Nation. So Warami Bujagar, which is hello and welcome in Darug language. So thanks very much, guys, for letting me come and talk about the Sydney Fish Market. I feel like I have a little bit of stolen valor because this has been a massive undertaking by so many people, including multiple architecture firms, builders, manufacturers, consultants. It's really been a big team effort. By way of background, Theca Timber, we are a supplier of glue laminated timber beams and cross-laminated timber floor panels. And we work with a couple of suppliers and manufacturers from Europe. And on this project, it's primarily from Rubner. So what you'll see here is some slides from the engineering team at Rubner who went through the detailed design development of that roof. Katie, can you just confirm for me that you can see my slides?
Yes, we can.
Okay, perfect. All right. So today I just wanted to talk to you a little bit about the design, the manufacturing, and then the assembly of the roof. As Katie just said, if you guys have any questions, just stick your hand up and I'll answer them, or you can hold them over to the end or chuck them in the chat and I'll do my best to follow along. So for those who are not based in Sydney, because I'm not sure where you're all coming to us from today, this is the Sydney Fish Market site on Wentworth Park in Blackwattle Bay. And this site was an industrial remnant, part of the old heritage of the harbour. It's a very commercial industrial wharf type facility. And it was right adjacent to the existing fish market. So the existing fish market is a very old and run-down facility, very internally focused. It was basically a giant loading dock with a few shops tacked on the front. And if you'd ever been, you would know that it was quite an experience, particularly if you go on Christmas Eve. It was absolutely jam-packed with quite a lot of mess going on. So it was really a great opportunity to redevelop not just this site, but also the precinct. So what has transpired since the Sydney Fish Market opened in its new location is that the entire precinct is going to be redone, completely renovated with new residential tower buildings going in over the next 10 to 15 years. So here you can see the new site in the existing facilities, and of course the idea was to relocate it, and once it was relocated, to renovate the old site. Interestingly, this project started all the way back in 2017 when architects AJC, or Alan, Jack and Cottier, did a reference design scheme, and they had an amazing, beautiful floating mirrored roof over some pavilions or shop stalls. And it's quite interesting to see that that design concept stood the test of time, because we still have a floating roof, of course, over the vendors. So the idea is to essentially have an auction and wholesale level on the ground floor plane, and then have a retail and catering and events public space floating over the top. So it's the retail activation, you come up and onto a level, and then above that sits some restaurants and a school for learning to cook seafood. Also, there's a wedding venue now, so you might be heading off to a wedding there for your family soon enough. The central piece for the design, though, was really the roof. The concept architects for this was 3XN, who are a Danish firm, and they really liked this idea of a floating timber canopy sitting over the top of open air stalls. They wanted it to feel like a large plaza, and they wanted people to sit and dwell and use it like a large piece of furniture. They really wanted people to sit there and enjoy their food and enjoy the weather. The roof is more than just a timber roof. It is, it's open to the air, it's naturally ventilated. It collects rain, of course it shades, but it also collects some power. I think 5% of the power that's used on site is by integrated PV panels on the roof. And the panels themselves are really quite ingenious. They do a range of things. They shade, collect power, but they also have smoke exhaust panels. They have electrical panels. It's all prefabricated off-site and then joined together on the roof. So this is the concept renders. And for those who've been there, you'll see that it's very true to life. I've got a couple of finished photos at the end. But onto the roof. So very early on in the process, it was decided that the roof was going to be in timber. In fact, 3XN's design concept was for timber, and that's probably an important learning for people in the industry, in the construction industry. It is very difficult to retrofit a design in structural timber if it's designed initially in steel. So by the client, who was the New South Wales government, determining that the concept design would be in timber, that meant that it stayed in timber throughout the entire procurement process. It didn't get value engineered out by a builder who was engaged to do a design and construct. And it meant that there was no questions and there was no sort of VE arguments about removing the timber. So that's kind of like a key learning for us, and the ideal type of project for us is one that's initially designed in timber, ends up getting delivered in timber. There's 584 unique beams. These beams are huge. They're up to 36 meters long. That leads to a crazy number of unique combinations. So 205 different types of load combinations. There were 7 teams involved, from architects to engineers to manufacturers engineers to transport and logistics to construction to fit off and finish. But that was all done in amazingly quick time. So 15 months, much faster than you would get for a similar design in conventional construction materials. The way that the timber roof really operates is that they lock together and onto these concrete cores, which braces the structure. The roof itself, you'll see, has a lot of these cross-bracing members. It's what's categorized as a diagrid roof. And a diagrid roof means that it's essentially self-bracing and ties back to concrete cores. Here you can see those the amount of connections that are required and the different conditions and typologies for those connections. So resolving all of these and then tying it back to the existing concrete structure is hugely complex, and doing it in a way that allows the timber elements to be manufactured is critically important to the procurement process. And that's why Rubner was so closely involved in the engineering of this job, because there was so much variety in the beam sizes, dimensions, and the connection types. So here's just one example of the connections. This is the architects and the Theca team who went over to Italy and were fortunate enough to see the sample. They lifted the sample up to the correct height so that you could see what the connections would look like from underneath. They didn't have the full-size steel columns, so that it's not a true mock-up, but this gave the architects and the engineers a good understanding of the size, the scale, the aesthetic, the colours, etc. This is also very important for Rubner to do the full-size mock-up, because even when you're designing and engineering the timber connections, you need to allow for things like people safely getting their hands up and into cracks and crevices to do bolts, and important questions like, can you fit a rattle gun into a very tight angled space? So this is why we end up building prototypes. So the next part is to really talk about fabrication and delivery. As I mentioned before, the timber elements came from a company called Rubner. Rubner are a very large glulam manufacturer from northern Italy, up in the Alpine region of the Dolomites. They have multiple facilities throughout northern Italy, also in France and Austria. And they're a family-owned and run business that have been around since the 30s and have been doing glulam since its invention in the 80s. Their facilities are really well established and quite sophisticated. You can see here they've got acres of solar, and they also draw from the grid in Europe, which is very green. They have a lot of hydropower in the area where they're from. And so that means that the inputs for manufacturing the glulam are quite green, and the embodied carbon associated with an individual meter cubed of timber beam, for example, is relatively low. So that's cool to know. They also give their staff electric vehicles to get around in between the factories. So, they're really dedicated to making sure that their operational emissions are very low. I want to show you a quick video. Make sure this doesn't skip one moment. Okay. So this is a quick video of the manufacturing of the beam elements. You can find this on the Theca Timber website, by the way, if you're interested, or our YouTube channel. But what you're seeing here is essentially FSC certified individual boards which have been purchased, and they get graded for strength, and they get automatically cut if there are any defects like cracks or knots. And then they go through a very automated production facility line which finger joints them together using low VOC glues with zero formaldehyde. And those individual boards get put into the press bed, which is what you're seeing here. So these beams are larger than usual, so they didn't use their automated press bed. It was still a very manual facility. Once the glue's cured, they go off to be hand finished. So they're planed, they have connections set into them. They get individually finished before they leave the factory floor, and this is a very efficient way of doing construction because it means less labour on site. The individual steel plates which connect the timber beams are actually set into the timbers. And once those rebates have been set in, the elements are then glued together. So it's a combination of very high-tech manufacturing with a lot of artisanal manual handling still. So it is really quite a unique and beautiful process. Just confirming you guys can see my slides again. Yep, cool. Probably one of the most interesting parts of this process as an architect is looking at the level of detail that goes into each individual element and steel connection. So there's a huge amount of shop drawing that goes into this. That's probably not that interesting if you're not an architect, but what it does mean is by the time that these timber beams get to site, there's very little chance of something having gone wrong and it just bolts together. And in fact, that is exactly what happened. There was 584 beams and not a single one of them needed to be modified. So that's pretty awesome. And you can see here like a little test plan for quality assurance, looking at the amount of knots and the connection and the color, etc. Of course, it's all well and good to manufacture these items in Europe. You still need to get them to site. And so a large part of what we do at Theca is the logistics and transport. Wrapping these elements up in protective material proved to be extremely important for Sydney Fish Market. There was actually, unfortunately, a collapse of a crane on site very early in the design development, which some people may remember, which led to a 9-month delay. So we were very fortunate or unfortunate, depending on how you look at it, that the wrapping was done extremely well, because this timber sat on the dock in Australia for 9 extra months, and no rain got into it, fortunately, and there was no issues with moisture or mildew. So that's just a good testament to looking after your timber, I guess. As I mentioned before, getting it to site is probably more than half the trick, getting it here to Australia. The Sydney Fish Market project was unique because we didn't use containers to get it to site. We actually used a regular bulk cargo ship. So what you're looking at here is the delivery sequencing. Here you can see the packing. So you can see the individual elements, how they would fit into the vessel, how they'd be stowed. And then once they were lifted onto the dock here in Sydney, how they would be stored on the dock, because you have limited dock space. So again, more sequencing images showing you how they're going to be loaded onto the boat. Actually, sorry, no, this slide is actually showing you how they're loaded onto the barge. So they were sat on the dock in Sydney, and then instead of being loaded onto trucks and delivered to site, we used a barge and used the harbour as the method of delivering it to site. So these are some barge sequencing plans. Images of them going into the bulk cargo carrier. This is not the most carbon efficient way of moving timber from Europe to Australia. Moving timber to Australia can be incredibly carbon efficient, and it can actually be a very good way of moving your timber around if you use containers. If you put 10 or 20 or 30 containers onto a container ship and move it from Europe, then your A4 carbon emissions or your transport emissions can actually be quite low, because you're splitting the emissions for that ship, 15,000 units over 10, 15 or 20 containers. So here we've got the container ship steaming under the Opera House. You can see there we shared the ship with a couple of luxury catamarans. So we weren't completely monopolising that ship and using the carbon emissions. We were sharing that amongst several deliveries. And then here you can see the timber being landed just under the Anzac Bridge. A couple of images of how the timber was protected. As I mentioned, it needed to be protected on site, and we also went over to site and made sure that the timbers were not getting wet by using moisture meters to check the relative humidity of the timber elements. Once the timber was ready to go to site, we would load it onto a barge. Here you can see they're using a mobile crane, and then that barge took the timber to the job site. This ended up being an extremely efficient way of moving the timber around, and it actually took several thousand trucks off the local roads. Now that's a good thing for the A4 transport emissions of carbon, but it's also a good thing for local residents. And one of the key reasons I think the government client was excited about this method of delivery was that they weren't having to add too many additional trucks to the road and disrupting the local road network. So installation, these are some images that I took on site. So these are incredibly large elements, say 1.9 meters tall, and they have huge steel plates in them. The installation sequencing is relatively simple. There were steel columns installed, and then the timber beams were lifted up and bolted off on the side, often with as little as 4 bolts like you see in this one here. And as I mentioned before, there were 0 modifications required to the timber beams or the steel connections. It all seemed to go together really well. I think there was one steel column which ended up being in the wrong place, and they had to cut it off and move it over and re-weld it on site. And there was also some concrete in the concrete cores, which wasn't exactly where it should be. And that's always a little bit stressful when you're building in timber. The challenge is always a timber to concrete connection. That's always a good one. It wasn't just the Italians showing the Australians what to do. This is a robo-rigger, which is a Perth invention. And the robo-rigger essentially sits between the tower crane hook and the timber element. And by having the robo-rigger there, which is essentially a huge gyroscope, you don't need to have tag lines on the large timber elements, so nobody needs to go really close to it. It's a lot safer way of working, and you get centimetre accurate control over exactly where the beam is being installed. You can see the installers who are kind of lifting the beam to the correct angle and then setting it onto the crane, and then the beams go up. There's some beautiful architectural details. If you ever when you go to the Sydney Fish Market and you look up, you'll notice that there are some really clean connections where you can't see at all, where there are cover plates or steel connections at all. That's because they were designed to go in, drop underneath the brackets, and then lift back up and be bolted off. So that's a really nice way of delivering the architectural intent. One of the key learning for this project was around temporary engineering. So on this project, as I mentioned before, there was several key stakeholders. So we had 3X and BVN on the architecture side, but we also had WSP, Enstruct, TTW, and Northrop on the engineering side, and each of them had their own distinct roles. And I think if we had coordinated better between all three engineering firms, we would have had smaller temporary proppings. But as it was, we ended up with quite large temporary proppings like you can see here. And it was quite expensive and it wasn't fully expected by the install team. So I think in future, like we will put more of a focus on the temporary works engineering package to avoid having oversized temporary works engineering like you're seeing with these huge mine props in orange. Really beautiful. This is up from the mezzanine levels, which are not open at the moment. Once some of the tenancies are fitted off, you'll be able to get up to these sunset mezzanines, and you can get really close to the timber. So you'll be able to see the European spruce. The European spruce was stained a walnut color, and it had 3 layers of finish put on it. Because it's not directly in the sun and it's not directly exposed to water or rain, it can work with just 3 levels of finish. And it'll need to be sanded back and refinished. We're saying every 5 to 8 years, but we actually think that it'll be more like every 10 to 12 years. We've seen projects in Europe which have lasted much longer than the specified sort of maintenance regime is written. What you're looking at here is the roof cassettes, which were prefabricated, which have been dropped on top of the timber beams. And then they came through and they did the electrical fit out and then put cover plates up. So it was a very fast and efficient system. And in fact, after the roof started going up, it took a little while to get started, but Multiplex really got into a rhythm and they saved multiple weeks on the program by getting the timber up early and then getting the cassettes bolted on quickly. So very efficient way of building. So there's a bit of before and afters. That's the render. That's the during. The afters are at the end. That's the before and the during. And here you can see the sequence. So the sequence really relied on the structural bays wrapping around those concrete cores and connecting into self-brace. Just want to show you. Oh, no, it's not going to work. I won't show you the video now, but if you'd like to see more of the install sequence, you can jump on the Theca Timber website. We've got a 5-minute mini doco there where you can see it getting installed. The final point I just wanted to land on was carbon. So there was an FAQ guide delivered by the New South Wales government, and I thought this audience in particular might be interested in that. So if you Google decarbonising infrastructure delivery using structural timber, this should pop up. And there's some key learnings here. So the first is that by using timber, you had a lower overall embodied carbon impact. So it's not just offsetting the steel, which would have been used, though that is the majority of it. It's also using less water and using less energy in the manufacturing of the timber beams themselves. The other second order benefit of using timber is that it's much lighter, up to 30% lighter dead loads than steel. And this puts less demand on the footings. It means there's less reinforcement and there's less concrete overall. And depending on the building type, that can be a really substantial difference in both carbon and also cost. It is quite difficult to cost in that benefit of having a lighter timber structure. And so a quantity surveyor who's doing like a pre-tender estimate or a budget estimate are often reluctant to recognise those savings in the cost plan because it is difficult to quantify, but it is a meaningful difference between timber construction and steel or concrete construction. Smarter logistics. So there was 995 barge trips backwards and forwards to the Anzac Bridge, and that replaced 5,650 truck deliveries. So that was a huge benefit, as I said, not just in carbon, but also to burden on the local road network. And then finally, as you saw, all of the connections are bolted. So it'd be very easy to rapidly disassemble this roof. And they are very large sections, which could very easily be reused in the future. I haven't heard of any projects yet that are being disassembled and reused. But it's in theory, it's possible. I think the only reason that we haven't really seen it yet is that we don't have any mass timber construction buildings in Australia that are old enough to warrant disassembly. There are some questions in my mind about whether and who would warrant the structural condition of a beam that has been in the previous structure. But we know that there are examples of that occurring now in structural steel where steels are being reused. So I think that timber, as buildings get a little bit older, timber is going to follow the same path, and we're going to see people warranting and inspecting timber beams, and then those timber beams being reused. There's essentially no reason why you would create a virgin glulam beam if a second-hand beam was available from another structure. So that's it from me. I'll stop sharing screen, and there's been a couple of questions, so I'm happy to jump into those.
Go for it.
Yeah. Just stick your hand up if anyone has any questions. So Tom asks, was the choice of timber initially and essentially an architectural choice or driven more by the upfront carbon reductions? My understanding from 3XN is that it was a very intentional choice by them, driven by architecture, but also by carbon. So over in Denmark, they have very stringent requirements on architects to reduce embodied carbon. In fact, I'm told by architects who work in Denmark that they open meetings by talking about their commitments to reducing embodied carbon, and they take it very seriously over there. And so if you look at the body of work of 3XN, you'll see they do take carbon reduction very seriously and are putting lots of effort into using timber in their buildings. Similarly, BVN, they've done some amazing work here in Australia with timber buildings. So I think it was a unique confluence of client hoping to make a statement, architect on board with producing a sustainable outcome, and then delivery architects who are technically capable of delivering that to the market. Mark asked, I had the same question as Tom, essentially given it was a government client. Yes, so the government, I think from very early on, even with that reference design that I showed you, wanted this to be a flagship asset for the government. They really were hoping to make a statement piece. So I think when they saw the design concept come through in timber, they really got on board with that as a concept. There's a question sent back for additional finishing every 8 to 10 years. How does that work, and why can't this be performed in situ? No, I probably misspoke. So it will be refinished in situ. So it's been engineered with attachment points so that you can get up there and you can sand it. You'll be using a boom lift and you'll have guys up there sanding it back and rubbing it. There's a lot of concern in the Australian market about using timber and its durability for Australian conditions. In Europe, they've had timber buildings around, well, since forever, but manufactured glulam elements have been around since the mid-80s. And so it's very well understood how a timber will age over time. Structurally speaking, there's no reason to maintain the timber element. It's essentially just an inert chunk of carbon sitting up there. But it will go, first of all, powdery, and then it will start to get surface checking, and then it will crack and go grey over time. There's no reason why you would need to refinish a timber element, but here in Australia, I think there's a lot of aesthetic preferences. Councillors don't want to see their timber buildings going grey, so we keep that in mind when we specify the maintenance regime. That date that I said there, sort of like the 5 to 8 years, that's when we start to think it'll start going a little bit grey. And I guess it's essentially up to the client when they want to refinish their timber building. If they're not happy with it and they want to finish it earlier because they want it to look new and glossy, then they can do so, but there's no structural reason why they would need to. Jason says, end of life for timber is interesting given the eventual degradation. Was that considered, or just the upfront carbon? It wasn't considered. So the idea of circularity with glulam elements is still in its infancy. As I mentioned before, there's some interesting things happening that I see in London, for example, where construction firms are buying old commercial buildings to mine the steel elements out of those buildings and reuse them. And that is more cost effective than them buying new virgin steel elements. And so that's really an interesting thing to think of in the context of a glulam structure like the Sydney fish market, because there is a huge amount of carbon embodied in those elements up there and a huge amount of money as well. And so it really would not make sense well, God forbid, it gets pulled down in 80 years. I hope it lasts 200. But when it does get pulled down, it does not make sense to imagine wood chipping that and burning it for energy and it all being carbon neutral. It makes much more sense to reuse that element somewhere else. And in 50, 80, 100 years time, when that building does get pulled down, like the timber elements that are already up there are going to be even more valuable than today. So I think there's obviously a lot of speculation about the economics of circularity, but for me, that's a very high value product that's sitting up there and it can be easily reused. That was it from the chat. Was there anyone else that wanted to ask a question?
Don't be shy.
Lots of people munching on their lunch, which is fine.
Okay. Well, if no one has any questions, there is one coming through the chat. Being so close to the water, is the salt considered an issue?
Good question. No, it's not. So there's no active spray in this area. So it is classified as a marine environment, but not a corrosive one. It's not too much of a concern. There is one example of a pool which was built in 1997, which is halfway between the Venice and the ocean, the Venice Lagoon and the ocean. And so it's been there sitting in a very corrosive environment. It's also a swimming pool, so it's chlorine corrosive. And the timber has done extremely well. In fact, it's the steel connections that corrode before the timber does anything that needs structural maintenance. So you don't really need to worry about putting timber anywhere corrosive. You need to worry about protecting their connections.
Yeah, Jan has put something in the chat following on from this. Were the connections designed to be concealed for this reason?
Yes, yeah, that's correct. So by embedding the connections into the timber, you protect those connections. They're not exposed to rain and fluctuations in humidity. So we've done that there on the Sydney fish market intentionally. You will obviously have seen that the columns are made out of steel, and so those columns will need to be maintained. And I would posit that those columns will need to be maintained more often than the timber themselves. Yeah, and that's the other reason why we do embedded connections for pools. is because if you put steel trusses up in a pool hall where there's a chlorine corrosive environment, it will need to be maintained regularly. Some products on the market say that paint products on steel are warranted for a particular amount of time, but we have seen projects in Europe which have lasted extremely well and not needed nearly as much maintenance as steel structures.
Okay, any more questions for Tim? No, everybody happy? Too easy, exactly. Well, it's a fantastic case study, a fantastic building. Thank you so much, Tim, for showing us this. I really love it. I haven't seen it because it is so popular, and part of that is because it is so beautiful, and it looks beautiful in the space when you drive into the city and you see it. Wonderful. I might use this opportunity. I'll send you in your day early, but I will use this briefly this time to talk about the working groups. They're all starting up if they haven't already. Tim's working group on engineered timber will be starting up on the 14th of April, and I will put something in the MECLA All Teams if you wanted to join. He's been joined by Jan Frampton from Hasselt as the co-chair. And they have yes, he is here as well. I can see him. Hi, Jan. Good to have you back here.
Good to be joining again. Yeah.
And they have a fantastic program. So I'll put that in the Teams all chat. If you were part of that working group before, you should have that invite in your inbox already. The same goes with Mark's working group. He's having a first meeting on the 17th of April. If you do have an interest in joining that, please reach out to info@mecla.org.au. And we will be sending out a survey to everyone from the working group on designing out carbon. That was also in the newsletter. They're also looking for people, and they're looking for input into the survey. That's going out next week. We do have a lot of events lined up over the next few weeks. We'll kick it off on the 23rd of April with a spotlight event on decarbonising data centre delivery. That's the work we've done together with the DBI. It is already on our website. It was already in the newsletter, but a specific invite is going out as well. And then we'll be at Sydney Build on the 29th and the 30th. We did get quite a lot of feedback from you all with interest to participate in some of the panels that they're offering. And not to toot our horns, but it's our 5th anniversary in April, and Emily will be at Sydney Build as well with the little camera. So if you are there and you want to leave us a short birthday message on video, please do approach us and we'll film it. If you have a sentence or two to say, that would be super lovely. And then the other 2 events are in May that we have already planned, and invites will be going out really soon. And that's 2 more spotlight events, one on the pouring pilot that we did with the City of Newcastle, on pouring low-embodied carbon concrete, and some spotlight event on the investor guidance we have been working together with the IGCC. That's pretty much everything from me. Do check the Teams chat, do check your inbox and your spam. If you think you're not getting the newsletter, reach out to us. And if you have any issues with the Teams access, do reach out to Emily and me as well. Otherwise, anyone else got anything else they want to add? If not, this is your time to speak up. If not, I wish you all a very happy long weekend. Take some rest, and we've recorded this. We will eventually put this up on the website, and if Tim is happy to share his slides, we'll add those as well. Thanks so much for joining us, and if you have anything you want to present to us, any case study, anything, please reach out to us as well, and we can facilitate that for the next month or months after that. All right, thanks so much. See you soon.
Thanks, Betty. Bye.
Bye.
Thanks, Tim. Thanks, Kati.
Thanks, Tim.
Bye.
Thanks,
Thank you.
everyone.